Awesome, guys. We come to our session of electrostatics right from grade 10 build to it actually stops in 11 but examined again in grade 12. So we're going to go through some concepts again, and this would filter into chemistry. For those of you that are in grade 12, it filters into what you call electrochemistry. It filters into stoichiometry. So please follow through as I take you through this journey. The first thing is to understand, I'll take you through grade 10, when we talk about electrostatics, it is the study of static electricity. And when we say we are studying static electricity, basically, we're looking at charges. We're looking at charges. And when we look at charges, instantly, we know we are dealing with positive charges, which are called protons. And we're dealing with negative charges, which are called electrons. So when we deal with charges, we're dealing with two types of charges, positive and negative charges. Positive charges are called electrons, and negative charges are called, positive charges are called protons, and negative charges are called electrons. Let me put the word negative there, negative, and let's put VE there for positive. Now, what I need you to quickly know is that they have, protons don't move, electrons move. Protons don't move, they are in the nucleus. Electrons move, and they move from higher concentration from a place of higher concentration let's say higher to lower concentration. When I talk about concentration, we can also use the word number. Okay. Now, both electrons and protons would have the same mass and the same value of charge. They would have the same mass. So, we're just going to say they both have the same charge, magnitude of charge, which is 1,6 times 10 to the power negative 19 coulombs. So if I'm talking about protons, then I talk about positive. If I'm talking about electrons, then I talk about negative. All right, so we know all of this, but it's just important to build from grade 10 again. Very important points that you and I would need to remember. Important points. We have already started mentioning them, but I want to put them in numbers. Number one, only electrons move. Let's put that down. Only electrons move. That's very important. Number two, electrons are negatively charged. Number three, like charges will repel. Number four, unlike charges will attract. 4 basic points there. I don't want to leave any stone unturned, no matter how small the information may be. Only electrons move. Electrons are negatively charged. Like charges would repel. Unlike charges will attract. All of this from grade 10. When charged bodies are brought in contact, we go back to point 1 and separated. Electrons move until we have an equilibrium. Such that Q nu will be equal to Q1 plus Q2 over 2. And if it's 3 of them, we have Q1 plus Q2 plus Q3. If you remember that. So charges move from where they, when we know that electrons move from where they are more to where they are less. Number 6, the number of electrons transferred can be calculated as N equals to Q. Let me write delta Q over QE. Delta Q, which is Q new minus Q old over QE. And what is our QE? QE is the charge on an electron. Just some quick things before we jump into the grade 11 part. So we can calculate the Q new by saying Q1 plus Q2 if there are 2 charges that are in contact. If there are 3, then we just find the average Q1, Q2, Q3 such that all the charges have the same. Number of electrons transferred can be calculated as N equals to delta Q. And once we say delta, Q new minus Q old. I've not done anything grade 11. I'm only playing around things we learned in grade 10. Once we are done, I'd like to move to the next page. Still on grade 10. I'll give you a couple of minutes. Once you are done, just start throwing up your thumbs for me. All right, I still have a few hands that I'm looking up to. Taisha. I have a few more hands that I'm looking for. Thank you. Gift. Nokukaya, are you done? Ontatile, Rosemary. Tehufatu. All right, thank you. There. Beautiful. Vera. Zizipo. All right, everybody seems to be done. Thank you, Kwezi. Thank you, Lino. Awesome. Busisiwe. Tato. Just checking to make sure everyone is done. Double. Just checking. Shandikani. All right. Malaudzi, are you done? All right, thank you, everybody. Now, let's look at field lines quickly. Field lines. Let us get confused on this, so we need to sort that out as quickly as possible. Field lines. Then we move to our grade 11 content. For field lines, we are going to look at isolated charges. That is, if I just have a positive charge and a negative charge, just a positive charge on its own and a negative charge on its own, what happens? When I have a positive charge on its own, please understand, if the examiner asks me to draw the electric field lines around us, please draw them as straight lines touching the object. The question would be, what is the difference between the positive and the negative? It must touch, please. Those are the rules. It must be touching. If it's not touching, we start losing marks. All right. Yes, talk to me. There's a hand. Kutlano? Oh, you're trying to help me. Arrows go outward for positive. Thank you, Kutlano. Beautiful. Arrows are moving outwards for positive. Thank you, Kutlano. Grade 10. And inward for negative. Please take note, they are straight. There are millions of them. They don't bend. They just don't, these things don't just bend. Some of us just have it as fun bending them. Question is, when do they bend? They only bend when they come close to another. So I'm just going to draw one attraction and one repelling. One attraction and one repelling. Of course, if it's attraction, opposite signs. And if it's repelling, the only thing that will be different will be the arrow. So if it is attraction, what happens? Don't draw too many stuff, okay? Don't draw too many. Once you start drawing too many, we're going to start creating problems. And then I have others still spreading out. From positive, it's going out. Those arrows are important. This is 3 marks. And I will be telling you where the marks are. Where are the marks? Arrows, lines don't touch, and the shape. Lines must be parallel. That's why they don't touch. Don't draw too many. The lines here, whether positive or negative, they'll have the same shape. The difference will just be the arrow. Since it's negative, we're talking about inwards. If it were positive, the same shape, we are only going to draw outwards. So here we have an attraction, and here we have a repulsion. And this is because we have like charges. Unlike charges. Okay, I am done with that. I'll give you a few minutes to draw. This is very, very important. Grade 12s, there will not be time to revise this before June exam. So this is your revision. So make sure your note is well written down. I'm going to cover every single thing possible. I'm going to do all types of questions. Graph questions, word problems. All types, simultaneous ones. And we are going to bring in Newton's law. So we're going to do force diagram questions as well. So it's going to be quite some intense activity. We will be pulling questions from grade 12 materials because we then expect your level of reasoning to also increase. And the star that I marked in the middle there, can somebody tell me what's going on there? I marked that star. What's peculiar about that point? What's peculiar about the middle point there? Anybody? Somebody? What do you think is going on at that point? Now, lady, you want to try? Okay, Kwesi?
I think it's that the lines shouldn't touch one another.
No. The lines would not touch at any point. Okay, Lemo has an idea.
Isn't it a test charge?
The what?
A test charge.
No. There's something about that point. Anybody? Anybody? Kutlwano, talk to me. Yes, Kutlwano, talk to me. Okay, Kutlwano, Sand's gone. Michelle?
There's no force of the electric field.
Sorry?
There's no effect or force of the electric field.
All right, there's no effect there. So at that point, we talk about something neutral. It's a neutral point. Because we are not experiencing any electric field there. It's a neutral point. Are we done with this page? We should be done while I was asking that question. If there's anyone who's still busy, just give me a thumbs down. If you're still busy, I know that you were drawing each line with a different color. Yeah, I knew that. So you know, you were drawing each line with a different color. Yeah, Zwelunga, you know that's what you do. Yeah, Venusha, you know. Okay, so everybody should be done. Beautiful. All right, so since we are all done with this, just a quick note. Let me see something. Should I put it here? Okay, I'll do it when I'm dealing with this. Now we move to the grade 11 part. We're still going to do calculations of the grade 10, especially when charges are transferred. Okay, Or let's look at an example quickly. Let's look at an example. Before I go to the grade 11 part, let's look at a quick example here. I have these two spheres, and we are going to put them on a particular type of stand. Does anybody have an idea what we call this stands? Yes. Anybody? Go ahead. I can't see my...
Isolated stand.
Not isolated, you're close. You check the word again, you're very close.
Insulated stand.
Insulated stands. Beautiful. Insulated, not isolated. And why do we put them on insulated stands? Yes, talk to me.
So the charge isn't transferred onto the poles themselves.
All right, so that charges are not lost. These are insulated stands. And this is to prevent loss of charges by conduction. So we prevent charges from being lost, because charges can flow. Remember, electrons would flow from where there are more to where there are less. Okay. I want to ask you a question. These things are brought in contact and separated. Okay. A and B are brought in contact and separated. Here's my question. Number one, state the law of conservation of charges. If you remember. Number two, will electrons flow from A to B or B to A? I want us to answer these two questions. Probably the first one you don't remember. I'll deal with that for you. But please tell me, is it going to move from A to B or B to A? Electrons move from where they are more to where they are less. Start throwing answers for me. All right, I'm beginning to see answers. B to A, B to A. Make sure you participate in B to A. Ooh, Vera goes the other way, A to B. Vera decides to stand out. B to A, there. Kutluano also joins Vera, A to B. Rosemary also joins the... Alright. Fatima also A to B. I wonder why you guys are deciding to be unique. Okay. We're going to prove it and let's see. Thank you for those answers. I love the participation. Let's take the law of conservation of charges quickly. The total charge in an isolated system is conserved during any physical contact. That is, if we calculate before and after, these charges will remain the same. Will electrons move from A to B or B to A? The answer is A to B. And the question is why? Let me help you. The more negative a sphere is, the more electrons it has. So A is more negative than B. So electrons would move from A to B. A is closer to the negative charge, to a negative number. If you look at your number line, the more negative a sphere is, the more electrons it has. A is more negative. I don't know if that statement makes sense. A is closer to the negative side of the number line than B. And we would prove it with a calculation. Please let me know if that makes sense to you, that it's from A to B and not B to... I did that on purpose because you are looking at the positive 12. Positive 12 means there is a lot of protons. The more negative a sphere is, this is still grade 10. But how do we calculate? All right, can I go to the next slide? Ribotile. You decided to leave me alone to be by myself today. Nice. Good. Good child. Well done. I would catch you. You know that. Okay. I'm sure I can move. I'm going to reproduce my page, and my third question, which would lead to the fourth one, and then we move to the grade 11 part, will be calculate the new charge on A and B after contact and separation. And all we need to do is to use our formula. QA plus QB over 2. The signs are very important, my good learners. The signs are very important. It is positive 8 times 10 nano plus positive 12. Remember what I said? If there were 3 of them at the same time, only at the same time, then we have to add all the 3 together. What would this be? 8 plus 12 is 20. 20 divided by 2 would give me 10. So each of them would have positive 10 times 10 to the power negative 9 columns. And my fourth question would be, calculate the number of electrons transferred. And for the purpose of proving our number 2 question, we are going to do it in both ways. We are going to use A and we are going to use B. I'll wait for you to quickly write the question and we answer. We are going to use A and we are going to work with B as well. I hope we are still progressing together. This is still grade 10. Yes, Untatile, your hand is up.
Sorry, sir, there's a mistake.
Okay, no problem. Okay, guys, let's walk through now. So we said N equals to delta Q over QE. So we're using A. Remember what I said my delta Q is? Q new minus Q old over the charge on an electron. Okay, so what's our Q new? It is positive 10 times 10 to the power negative 9 minus, what is the old value of A? A was 8. Positive 8, right? Don't forget the signs are very important. We are going to move to grade 11 now, where the signs will no longer play a role. But what's the charge on an electron? Negative 1,6 times 10 to the power negative 19. Please, when it comes to this section, I'm going to guide you and use a calculator with you. You use this division line. Very, very important. All right, positive 10 times 10 to the power negative 9 minus positive 8 times 10 to the power negative 9 over, I'm using the times 10 at the bottom, negative 1,6 times 10 to the power negative 19. I'd like you to get your calculators and confirm with me if this answer is the same as what you have. Confirmed? Negative. Negative means I'm losing. Negative 1,25 times 10 to the power 10. Therefore, 1, times 10 to the power electrons are lost. We are using A, right? From A. That's what the negative tells us. The negative tells us that that is lost. If I were to work with B, the same formula, delta Q. Now, what is our Q new for B? Positive 10 times 10 to the power negative 9. What's our old value for B? Positive 12 times 10 to the power negative 9 over negative 1,6 times 10 to the power negative 19. I promise you are going to have a positive answer, which therefore means that what? 1,25 electrons were received. Because our answer is positive, are gained by B. Can you see? A loses electrons and B gains the electron. Keep writing. I'll just do the calculation for you. Positive 10 times 10 to the power negative 9 minus positive 12 times 10 to the power negative 9. I'm doing the calculation for you so that you focus on writing, and then we move to the power negative 19. My answer is a positive. And this confirms what we said, that it moves from A to B and not the other way around. All right, let me know if once we're done. Okay, let's move to the grade 11 one now. Let's move to the grade 11 concept. All of this is grade 10, which is good in foundation building. Can I move? Thumbs up, thumbs down, let's see. All right, there's a lot of go ahead. Beautiful. Now, grade 11 part, as we shoot now. All right, do I need to stay? Who gave me a thumbs? I'm not sure whether it was a thumbs up. I just had a sound.
Yes, sir.
Great.
So when I have it on my calculator, it says 1,25 times 10 to the power of negative 18.
Did you use this division line that I used?
Transfer?
Did you do it exactly the way I did it? I told you when it comes to this topic, you use that.
I placed those values, yes, sir.
Okay, which one? Is it for A or B? Let's confirm together.
For B, I got an exponent of negative 18, and also for A, I got an exponent of negative 18.
Did you press it the way I pressed mine?
I'm not sure how did you press yours, sir?
Like that, the way I wrote it down. Exactly what I wrote. I just transferred it to a calculator. Maybe you made a mistake. You pressed negative 9 instead of negative 19 at the bottom. Check your calculator, check the exponents.
Oh, sorry, sir. Yes, sir. Okay. Thank you, sir.
All right. Okay. My good learners, we go to the grade 11. Coulomb's law. Coulomb's law. Now, this is completely similar with universal gravitation that we did. Okay? Coulomb's law. The magnitude of the force of attraction between two charged objects is directly proportional to the product of the charges. If I was doing Newton's laws, I would say the masses, and inversely proportional to the square distance between them. I'm going to write a common mistake that we Nellas usually make between them, and here is the caution: not their centers, please. Why? Charges are too small in size. They are so small in size that to now measure the center, it makes no difference. Okay, so F is directly proportional to Q1, Q2, and F is inversely proportional to the square of the distance between them. Therefore, F can be written with a proportionality K, Q1, Q2, over r squared. I have 3 graphs to quickly draw on that. And if you guys remember, we did quite some things when the examiner was talking about, we were talking about changing masses, reducing the distance. We did all of those. That automatically applies here as well. I have r squared 1 over. These ones are directly proportional, while this one is inversely proportional. Just some mathematical representations here. So here, just some mathematics quickly. Our gradient is fr squared. So our gradient is k, q1, q2. Very important. Okay, quickly write this. I'm going to explain what I wrote down there. I didn't want to forget. That's why I went ahead to write it for you. So if we look at the gradient, change in y over change in x. Gradient, change in y, I'm now explaining, I want to believe you are with me now. Change in y over change in x. Alright, so it is change in y. I'm writing it like this for easy mathematical representations. Is change in y over change in x, which is f over 1 over r squared. But to make it easy, I'm writing it as f divided by that. And mathematically, we change the sign and flip that, right? And that gives us fr squared. Now, if you go back to your formula, quickly look at where on the left-hand side, f equals to k q1 q2 over r squared. If I cross multiply, do you notice fr squared, therefore, is k q1 q2? And that's a very important, that's very important mathematical manipulation. Please let me know if you understand the mathematics I did there, if it's okay. The maths I did, cross multiplying, dividing. That's a very important concept, because we're going to need that when it comes to a graph. You're given a graph and the examiner is going to give you lots of nonsense and jargons. We must be able to do that. All right, now having done this, we're going to pick a question quickly and try to look at a question. All right, but before we look at that, we can apply Newton's third law. If object A exerts a force on object B will simultaneously exert a force on object A, right? Applying Newton's what? Third law. The force of attraction between object A and object B would actually be the same. So we're saying FA is actually equal to what? FB. Okay, let's move on quickly. Before I go into calculations, I quickly want to do something here. I want to talk about net force, because we're going to come across that quickly. Net force. This happens when we have more than two charged objects such that we have two separate forces we apply our knowledge of Newton's law. By drawing a free body diagram. By drawing a free body diagram. Okay, beautiful. So we're going to calculate force, and we're going to calculate net force. I want to do my calculations on the next page. I have one more page, one more slide. I'm just thinking of using it now. And then we jump into calculations together. Electric field at a point. When I do calculations now, it's just going to be one flow. But would be slow enough for everyone to catch on as quickly as possible. Electric field at a point. Let us get confused with two specific definitions that I'm going to clarify now. There is what you call electric field. Now, when I say a field, what comes to mind? You're thinking of a sports ground. So it's a ground, it's an area. So electric field is the area around a charge where the electric force is felt. Or experienced. So we talk about the area, it's a space. But when I go further and say electric field at a point, I'm going to help you here by using the formula. If once you know how to use the formula page, you'll be okay here. I'm going to write the formula first. E equals to F over Q, where F is the force experienced by a charge and Q is our unit charge. So this is how we learn definitions in physics. If you forget, you go back to your definition page and work with this. This line means per. Therefore, I can do my definition and say electric field at a point, I'm just going to write those words that I wrote, is the force experienced per unit charge. Force experienced per unit, you can put point charge. Per unit point charge. And our unit is, remember, okay, let's do this. I'm just telling you things that you shouldn't forget. They are skills. This one is measured in Newton, and this one is measured in coulombs from grade 10. Oh, so our unit is what? Mathematically, N over C. Oh, and that can be written as N C to the power of -1. So if you forget the formula, if you forget the unit, use the formula to recreate. So that's the beauty of physics here now. All right, if you are okay with me, then I'm happy. If there's no question, let me know if you are okay. We're going to jump into calculations. I'm going to lead these calculations for now. Going to look at different types of calculation now. Newtons per coulomb. Basically, the theory is done. We're done with the theory. We're basically done with our theory. Oh, let me just put something here. Point charges are positive. Yes. Somebody is talking there. Before you write that, let me just do something. Doesn't matter even if you've written it. Somebody's saying something. E net, therefore, is F net over Q. Point charges are always positive. Take note. Now I'm just introducing my net formula there. Somebody was raising a hand. I don't know if it was to ask a question.
So I was saying.
Limo, could you say that again?
Can you please go back to the previous slide?
Okay, I will do. Are we all done with this page? So we can go to the previous slide for Limo, and then we come back. And when we come back, we're just doing activities. Let's see if we can get 2 questions done today, and then next week we do a lot more, then move on. Limo, give me a thumbs up if you are done with this page.
So the other one.
I should go for
Before this one.
Okay, this one.
Thank you, sir.
You are most welcome. Okay, guys, let's jump and look at a few questions that the examiner would want to ask us. So I like to do this with you, where we pick questions together. you know. I just enjoy it, where we together look for questions, resources, physics. Just gonna go to a grade 12 paper, random paper, and let's enjoy. Let's go to 2020. Let's enjoy the paper. We have quite a number. Let's start from November. So grade 12, I'm showing you where you can get questions to practice and to let you also know that this is tested in grade 12. So here we go. I'm going back up. You know why I'm going back up? I'm going to look for multiple choice. There we go. Everybody, read carefully and give me an answer. You have 2 minutes. This one is 3 marks once you are done reading. I need a response from you, whether right or wrong. If you are lost, I still need a response to say, I'm lost. No one is keeping quiet. Okay, answers are beginning to come in, so I'm checking. All right, you guys are giving me A. What is my own answer? My own answer is also A. Okay, because we even did a calculation. Thank you, guys. We did a calculation earlier on, but I think it's important. Let me just go back there and do something. Okay, until we have an equilibrium such that Q new. Okay. Let's just put something here, very, very key. What does this mean? It means Q1 new would be the same as Q2 new. Both have equal. I want us to spell it out. Both have equal what? Charges. I want us to spell that out clearly. Very, very important. So that is well spelled out. You're not mistaken. You're not guessing. It is well spelled out. Q1 new equals to Q2 new. Both now have equal. And we did our calculation to prove that. Okay. I'm sure you've added that little note. And I can move on. Beautiful. Now let's go look for structured question in this paper. So if you are picking a grade 12 paper, you'll find it at question number 7. Aha. There we go. I'm going to work this out with you. Don't stress. Ooh, we're starting with something very high. We're starting at the deep end. Okay. So you can make a note. It's November 2020 paper, grade 12. Should you want to make reference. And somebody can take a screenshot and please send on the group, because you won't be able to write all of these questions down. Whichever group you are in, there are 3 different groups in this class at the moment. Just please quickly take a picture. And I'm looking for, on my phone, I should be getting 3 pictures. Or 1 picture 3 times. Don't wait for anyone, even if it's 2 people taken per group, it doesn't matter. Thank you, Fatima. That group is sorted. All right, thank you, Tawana. Thank you, Grace. All right, thank you, Grace. Every group is... Now, let's read. 2 small charge spheres A and B are placed on insulated stands. We spoke about that, right? 0,2 meters. Oh, I need to give you conversions. I'll give you that. Somebody remind me after this. As shown in the diagram below, they carry a charge. Please never write your charge without a sign. It must either be positive or negative. That's very important, except the examiner is asking you for magnitude. M is a point that is a distance 0,1 meters to the right of B. Let's start. I'm going to start by, all right, it's fine. Yeah, okay, I need that question. It's there. Number 1, calculate the number of electrons in excess on sphere A. Number. Look, the examiner is very clear here. They want the number of electrons. There's only one formula for that. And this time around, please take note. The electrons, the charges are not brought together and separated. Please. They are not brought together and separated. Here we just use N equals to Q over QE. And we are done. 3 marks. N equals to Q over QE. Number of electrons excess. Usually it should be 0. Why are we saying excess? It's now -4. It means we have more electrons from its neutral state. Okay, quickly. Number 7.1. Like I said, I am leading this set of questions. 7.1. N equals to Q over what? QE. 1 mark there. What is our Q? -4 times 10 to the power -6. And the charge on an electron, -1,6 times 10 to the power -19. Remember, they are both in columns, so that cancels. Unit, very important. Put this on in a calculator. All right, -4 times 10 to the power -6. Over -1,6 times 10 to the power -19. 2,5 times 10 to the power 13. Please confirm if that's what you have as well. There must be a unit there, number of electrons. 1 mark there, 1 mark there, and 1 mark there. 3 marks in the bag. Three marks in the bag. I'm sure that's simple enough for everybody. So, the first question is a grade 10 question. Beautiful. I love the progression. We actually chose something nice. First question is a grade 10 question, calculating the number of electrons. Now we go for number 2. Everybody okay here? Calculate the magnitude. You see, the magnitude. Okay? The magnitude of the electrostatic force. That's very important. We are looking for F exerted by sphere A on B. This is grade 11. All right? This is grade 11. Magnitude of the electrostatic force. We know our formula. What is F? F equals to K QA QB over R squared. Now somebody is saying, okay, what is my K? Now guys, the examiner says magnitude. Please listen to this part. I am no longer going to use my signs, but let's together fetch the value of K so that you also see where K is. You go to your formula page, and look at the value of K. It's a constant there. 9 times 10 to the power 9. Look at the unit. Newtons meter squared per column squared. But don't worry about the unit for now. Okay, please write down the value of K. It is, please be careful of the exponent. 9 times 10 to the power 9. We move. 9. Now, what is QA? I am not going to write the sign anymore. The examiner is looking for magnitude. What about B? What's our B? 3 times 10 to the power negative 6. And what is the distance between A and B? Ooh, red. What is the distance between A and B? 0,2 meters. Don't forget, it is squared. Please put this in a calculator. I want answers to come from you. 3 marks as well. I want answers coming from you. Oh, you guys are fast. 2,7 newtons. Please let me know if we are all on the same page. And definitely, that's the same force exerted by B on A, according to Newton's third law. So some examiners will ask you for that. That without any further calculation. All right, 7.3. Oh, describe the term electric field. We described. Now, this is not at a point. What is this? A space or region around a charged object where the electric field is experienced. I did specify the difference between the two. Electric force. Please, very, very important that we know the difference. 7.4, so that we just copy and paste. 7.4, calculate the magnitude, my good learners, of the net electric field. Okay, please, whatever I do now, I'm supposed to give you the second formula. Guys, let's go back to electric field. There are two formulas. Oh, I forgot. Now, let me give you the second one. Let me give you the second one. It's just skipped my mind. E can also, let me put it in a bubble here. E can also be calculated as KQ over R squared. E can also be calculated as KQ. Now, this is not Q1, Q2. KQ over R squared. Although we get that formula from that E equals to F over Q. Okay. KQ over R squared. Take note of that. We're going to rewrite it now again. But here's the key. The word net, I did explain what it means. It means there are more than one. Please follow me. At point M. Okay, this is what we are going to do. Let me do it this way. Please follow here. Every time I see the word net, this is what I'm going to be doing. Whether net force or net field, doesn't matter, we do the same. Where is my, 1 second, can't find my, okay, I'm stuck. Let me see. What's that one? Okay, I am stuck here. This board is not doing what I want. 1 second. Let me use a mouse to force it to do what I need it to do. All right. I am completely stuck. It's refusing. Ooh la 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 la. What am I going to do here? Let me see if I managed. Okay, just 1 second. Let me just save in case, because I don't know what's going on here. Just 1 second. All right, I don't know what's going on today with this board, but okay, I got what I wanted, and we just managed through. Okay, guys, let me just manage whatever I see, as long as you can see. I don't know what's going on. Something is... Okay, we are looking for the what? The electric net. Please remember, the examiner is using the word net. Net electric field where am I? Net electric field. Whenever you see the word net, please start by drawing a free body what? Diagram at M. M is a point charge. And what are point charges? Are they positive or negative? Point charges? Plus or minus?
Positive.
Thank you, Naledi. So smart. Positive. Now we're going to draw a free body diagram. I'm going to put a dot there. Remember, my B is positive and my A is negative. Now, my good learners, please check. If I am looking at my positive, my M, I'm using a free body diagram there. Let's consider, forget about A now. I wish I could block it. Consider B and M. What do you think will happen? I have positive and positive. Is it going to be attraction or repulsion? I am considering B now. Forget about A. B is positive. M is also positive. Is it an attraction or a repulsion?
It's a repulsion.
Thank you, Lemo. Lemo, keep your mic on. I want you to answer this question. Where do you think M will go to Will M go towards B or away from B? Limo, are you there?
Away from B.
Linda helped you out, Venetia helped you out. Away from, because it is repulsion. Repulsion means it is pushing it away. Let me know if that makes sense.
Yes, it does.
Repulsion. Beautiful. Okay, now we are done with, I said A. I wrote A. I was supposed to write B. Why am I writing E? We are looking for electric field. If we're looking for electric force, we would write F. Yes, talk to me. Limo? Your hand is up.
So if I would say it will move away, but then I say to the right, is that correct?
Yeah, it's still correct.
Okay.
All right. Now let's consider A and M. Remember, I am done with B now. A and M. What do you notice? A is negative, M is positive. Do you want to tell me where it will go through? Left or right? Okay, we are looking at A and M now. How will M move due to A?
To the left.
To the left. Why? It is
Because
attraction.
it's attraction.
Beautiful, Nana. You're so smart. Attraction. Okay, the magnitude of the arrows will not really matter in this case. I just want to. The magnitude of the arrows will not really matter. Okay, guys, that free body diagram is so important. I'm going to redraw my free body diagram. Sometimes the examiner would ask you to draw, and sometimes they don't. If they don't, you draw. It is very, very crucial. Beautiful. I have that. Now, according to Newton's laws, it's a force, so I'm going to take direction. Let's take right as positive. Remember, you can take any. So what is E net going to be? Since I'm choosing right as positive, it's going to be negative EA plus positive EB. Let's see. Is that making sense to everyone? We're back at Newton's laws. I'm taking right as positive. It means left, and the one that is moving left is negative. Guys, this is how you outlay your work. Don't do shortcuts. You outlay exactly the way I'm doing it. Okay. Now, E net would be equal to negative KQ. Now I'm dealing with A there over R squared plus, I'm just substituting now. Please let me know if my substitution makes sense. I have already said you can rearrange it by saying EB minus EA. It's fine, doesn't matter. And remember, my E equals to what? KQ over what? R squared. So I'm now specific when I say A. Now it's simple. Negative 9 times 10 to the power 9. Don't worry about the sign of A anymore. When we substitute, we do not substitute with the signs. We just take the value. What do I have? 4 times 10 to the power negative 6 over, my good learners, please watch. I am dealing with A. Remember, it is between A and M. We are looking at A and M. What's the distance? A and M. What is the distance?
0.3.
Oh, beautiful. Oh, you guys are on fire. 0.3 because we're adding. Plus, now what is my K again? 9 times 10 to the power 9. What is my QB? 3 times 10 to the power negative 6. Now, what is the distance between the two? Between B and M, 0, 1. And we are done, my good learners. All you need is a calculator to help you out here. Okay, plug this in a calculator. Let's see what our answer would be. Guys, if you write nicely, you just plug it in nicely. Negative 9 times 10 to the power 9 multiplied by 4 times 10 to the power negative 6 over, don't forget your square, that's where we make mistakes, plus 9 times 10 to the power 9 times 3 times 10. I love this question. It's quite basic and we can start doing crazy stuff from here. Just put that in your calculator and get your answer. 23, what? 1, 2, 3, 4, 5. I have 5 zeros. Oh, that's what you have, Quasi. Is it 27 or 23? I'm getting a 23, Quasi. Did you put a squared? Okay, can people confirm? All right, it's a 23. And you can write this, we normally write it scientifically. Shift, mode. All right, once you press shift mode, I want scientific notation. It's 7. And I want 3 numbers because we always round off to 2 decimal places. So I'll press a 3. 2, 3 times 10 to the power 6. And what is my unit? Newton per coulomb. How many marks was this? Sorry, 1 second. 5 marks, I think. Beautiful. 5 marks. 5 good marks. Definitely my answer would get 1 mark, 1 mark, 1 mark there, 1 mark for the formula. And 1 mark for the signs where you're adding and subtract. Let me check something. Are we looking for the magnitude? 1 second, sorry. Yeah. Okay, so the examiner decides to give an extra mark. I'm sure for choosing the position, 1 mark.
So could the other mark be for saying E net is equal to negative EA plus EB?
Not really. Let me check. Let's check what they did here. Let's check together. Because they should have given 4 marks there, but let's see. Oh, I have a paper 1 here. I don't have the paper 2. But yeah, since they gave 5 marks, you see where I put that other one, that takes care of the negative. Okay, let's put that mark here. Then the formulas, 1 mark. Each substitution gets you a mark, and the final answer gets you a mark. Okay, Quasi, there's no right here. That's why I want to check the question. The examiner says magnitude. Okay, if they didn't say magnitude, then I'll have put to the right. Guys, did this make sense? So anytime we see the word net, it means we need to calculate 2 things. And you cannot calculate the 2 until you draw a free body diagram. Our next week's session will just be calculations. Yes, can I take your questions, Fatima?
So if they don't calculate the electric field, would you include the sign?
Sorry?
If they told you to calculate the net electric field without saying magnitude, would you include the signs?
No, we'll do it exact same way.
Okay.
The signs, let me explain why I'm not including the signs. Good question. You see your free body diagram. Here, we have used the sign. This is where the sign played a role. The signs played a role here. Signs were already used here. That's why we're talking about attraction or repulsion. So whether they tell you magnitude or not, we do the same thing. The only difference would be your final answer. The final answer would either be like this or have a direction. In this case, right, because our answer is positive. Can I take more questions? Yes, Limo?
So, sir, if they didn't say that we should calculate magnitudes, then our answer would be 2.3 times 10 to the power 6 newtons per coulomb to the right.
Yes. That's what our answer would be if they did not say magnitude. It means we need both magnitude and direction. Kwesi?
So the electric field on A on M, would it be the direction be on the left side, right?
Yes.
Okay. Thank you, sir.
All right. Any more question? Okay. This looks like a very good start. This looks like a very, very good start. We started well. It looks like a very, very good start. We can then proceed with other questions in our next session. So next session is just going to be questions. We're going to try to see if we can do about 10 different questions. I'll do some, you do some. We do questions with strings. We do question in the vacuum. Yes, Limo?
So you said we should remind you for the conversions.
Oh yeah, Nana, thank you very much. Let's conversions. You're such a star. And then we shut down after that. Conversions, very important. Conversions. Okay. Q is measured in columns. But what the examiner would give you, they'll give you 4 of those. All right, they'll give you 4 of those. Millicolumns, microcolumns, nanocolumns, and pico. This is times 10 to the power negative 3 columns, times 10 to the power negative 6 columns, 9 columns, R is measured in meters. So what they will give you is millimeters and centimeters. You must convert to meters. The word cent is 100. So what do you do here? Just 1 second. From here, you actually divide by 100 to get to meters. Here, you divide by 1,000 to get to meters. And those are the little things that I needed to know. Just those little things that I needed to know how to convert. Micro times 10 to the power negative 3. Then you have times 10 to the power milli. All right, milli. Then you have your micro. You have your nano. Nano sounds like a 9. And then you have your pico. Yes, Naledi?
So would they give us the distance in kilometers?
Not really, because we're talking about small objects. Charges are always small.
Oh, okay, thank you.
All right. Okay, guys, nice introduction. If there is no more question, I'm done for my first lesson, and we can just do the second one later on. Are we good, everybody? No questions? Beautiful. Just an easy way to get good marks. Lovely. Awesome. Guys, you are most welcome. You are most welcome. Have a lovely evening. If you don't have a question, you may please leave the class if all is okay. Thank you. Enjoy your evening. Bye, Rosie. Ta-da-da-da-da. Bye, Michelle. Bye, Kwezi. Bye, everybody.